Evening, folks. Brian here. It's Monday, December 9, 2024. We need to keep an eye on the north end in the Pacific, where we're having our earthquakes, our low pressure systems over the next few days, week. So I'm just going to take you a few hours at a time ahead. Let's see here. What am I looking for? So here's one. The pressure is going to be down to 956 hectopascals. It's moving on up to the tail end of the Aleutians. 943. Our earthquake happened right here. This is going to be Saturday. It's going to expand, but it's going to rise a little bit. 944. So this is where our earthquake is, just south of Adak. It'll be Sunday. And it's going to be moving up along the Aleutians. The reason why we watch the low pressure systems, low barometric pressure, when you have a drop in low barometric pressure and atmospheric temperatures, this allows for an increase in muons, the secondary charging particles of the cosmic rays, to penetrate through the crust and excite the silica-rich magma, causing its ascent up through the mantle plumes, resulting in earthquakes and volcanic eruptions. I'll show you an example. So in this graph, the blue line represents the barometric pressure, and the red line represents the number of muons. So you notice that when our pressure is high, we have a low muon count. When we have a drop on our barometric pressure, we have an increase in the cosmic rays, muons. High pressure, low muon count. Low barometric pressure, high count. High barometric pressure, low muons, and so forth. So again, this is current time. So my theory has been, and as it's been shown many a times, after a low pressure system passes over a certain area, it can be up to 5 days, we have a seismic response. Well, this will be a Sunday. This is where our magnitude 6.1 or 6.3 earthquakes happened. Our pressure will be quite low at 943. Quick look at the rest of the world. That is all.